So I had a pile of small coins in a jar up on my shelf in my room a few days ago. And I needed to figure out how many I had. Simple task. A game of guess how many insert item here are in the jar didn't exactly sound appealing to me. So the jar was upended out into the table and I began to count. I had a few 50-cent coins, some 20-cent coins, lots of 10-cent coins, and many 5-cent coins. And the arduous process of counting them began. About halfway through the daunting task, my brother came in and posited a question. The specificity of this question is relatively unimportant, but all that matters is that there was a distraction. Frustratingly, I then forgot where I was, and I needed to start the process all over again. Another few minutes passed, another distraction. I consistently lost count. What was happening to me? This was a task that was so simple and mundane that it should prove easy for me. Yet the process seemed more troublesome than I had imagined. Why was it that I needed to remain focused on the task throughout to succeed? Why was I losing count? So, prior to the advent of farming and commerce, humanity was a nomadic species, for which counting was not particularly necessary. As long as your tribe was not losing members, you didn't really care about the exact specifics of the quantity of people who associated themselves with you. It didn't matter if there were exactly 12 or exactly 13 or 14 deer in the nearby field, just that you viciously shot enough to fill stomachs sufficiently. When the advent of agriculture passed, then counting became necessary. Sometimes words denoting unspecific quantities, like few, some, lots, and many, are not accurate enough when certain problems require specificity. With farming came trading, and with trading came winners and losers in commerce. If you're expecting, let's say, some livestock in return for bushels of wheat, then an exact head count is crucial to save yourself from the proverbial short end of the stick in the exchange. When we are taught numbers in school, they are rote learned, the underlying maths put aside for a while, until students comprehend how to read, write, and speak numbers. The symbol 1 is pronounced 1 and comes first. The symbol 2 is pronounced 2 and comes next, and so on. It is almost poetic or rhythmic to recite the counting numbers. Its repetitive and predictable pattern becomes apparent to students after a certain point. I distinctly remember the point at which I realized counting from 20 to 29 is the exact same in English as 30 to 39, replacing 20 with 30, and how much the same occurs for many more numbers after that. After a certain point in the learning process, native English speakers only need to study a few new words to regurgitate a vast bulk of counting numbers. When absorbing the lyrics to this poem of counting numbers, the most urgent thing for students to tackle is to digest the order. 1 must come before 2, 2 before 3, and so on. Order is easy for us to understand, and this becomes completely habitual after learning it. We do not really need to comprehend what every counting number represents. Think about how incomprehensible a million things are. Yet we all know that a million falls between 999,999 and 1,000,001. And if we had enough time, patience, and maybe a few screws loose, we could recite an ordered list of symbols or words to represent all of the numbers from 1 up to 1,000,000. This concept is known as ordinality, being able to line up each number in an exact order. Many of the early problems we come across deal with groups of things, like all varieties of fruit, animals, and whatnot, with which students are adding quantities together, subtracting quantities from each other, and comparing quantities. These introduce the core notion of size. In mathematics, we have a word for these groups of things, and they're called sets of elements. A set is a group, and the elements are the things in the group. When discussing how many elements in each set, we call that number the cardinal number of the set. After some time, students develop a comfort with the fact that counting numbers often represent a quantity. This concept is known as cardinality, being able to say how large sets are. Cardinality brings with it a few problems, however. Humans find it problematic to subitize. If you crack your eyes to see a magnificent meadow, you can instantaneously and confidently say that the grass is green and the sky is blue. It is difficult, however, if there are several sheep in that meadow, let's say, to have the same judgment with both accuracy and confidence about how many there are exactly. It is not an instinctual gift for us, unfortunately. Subitizing is a fancy word for that idea, of right away, immediately knowing exactly how many coins lay in a pile or animals in a pen without having to think, no matter the size. We all, as humans, have silly, stupid brains that can't subitize, and we needed to develop counting to help us out. Is there some way of knowing that we can't subitize, other than prior knowledge from everyday life? Example being how tough it is to gauge how many coins there are in a table or sheep in a field. There is some circumstantial, albeit evidence, for our inability to subitize. It is baked into the way we write our numbers. Many know the infamous Roman numerals, but not as many know the traditional Chinese numerals. These two systems share a trait that provokes an interesting question. The first three numerals in both systems are written as groups of lines corresponding to the quantities. And one might be forgiven for thinking the fourth numeral would just follow suit and just be 4 lines, horizontal in the Chinese case and vertical in the Roman case. However, in both systems of writing, the fourth is a deviation from the norm. Why would the number 4 not just be written as 1 to 3 were? Perhaps some ancient accountants would get mixed up between 3 and 4 often enough for it to be a problem. And they got fed up. Instead of dealing with the frustration due to a similarity between the numerals for 3 and 4 and their inability to subitize between them, they changed the 4 numeral to look different, and it became a unique character. This would describe an effect, an immediate effect on the way numbers are written, explicitly because we cannot subitize well. So why is it that we find it tough to subitize? Once we become more accustomed to problems with counting numbers, we realize that sizes of sets are comparable. One set has a greater number, a lesser number, or the same number of elements compared with another set. If I were to unveil 2 groups of unarranged dots and ask you to compare them in size, it would be easy enough to deduce for small quantities. Obviously, 2 dots are less than 3, which itself is less than 4, and so on. However, when I show you 87 dots and 88, not so trivial. Imagine the difficulty of discerning 1,000 and 1,001. This is precisely because relative sizes are a hindrance to our understanding of counting. The word relative here represents the fact that we're comparing. If we were to behave in a way where our initial instinctual perception of relative sizes are of utmost importance, it would be our initial instinct to say, well, there's a noticeable difference in size between 2 and 3. It's a 50% increase. And a slightly less noticeable, although still significant, difference between 3 and 4, a 33% increase, and so on. We then developed this idea that consecutive numbers almost become more similar as they increase in size. This perception can be represented by a number line, where the gaps between numbers get narrower as we move higher and higher in the order of counting numbers. To develop a method of understanding quantities larger than our brain can comprehend, it is imperative to shelve this interpretation at some point though, and say that, no, the difference in size between 2 and 3 is 1, adding 1 to 2 is 3, and the difference in size between 3 and 4 is 1, adding 1 to 3 is 4, and so on. Or in other words, that constant gaps exist between consecutive numbers, no matter where on the number line they fall. So when we combine the ideas of ordinality and cardinality, we arrive at a way of coming to terms with difficult larger quantities. Each number sits somewhere in the order of our poem of counting numbers, and this order is determined by the increasing size of the quantities, each time larger by 1 more unit. This is learned or taught rather than an instinctual response. When we do not know the exact amount of an item in a group, we use counting. We take one item out of the group and place it in a new group, initially on its own, and we say 1. We know that 1 is the first in our line of numbers. Then we take another item out of the group and place it in the new group, now with 1 more item, and say 2. We know that 2 is second in our line of numbers. We do this until we exhaust the number of items and have accounted for them all. If you think about it, we do not really comprehend the size of the group until this very moment of completion. We avoided thinking about how large our set was and just recited our poem for a given number of steps until we know we're finished. The last number we speak corresponds to a location in our order, but also to the size of the group. Counting uses order to dance around a concept we struggle with, like size, by aiding our comprehension with another, easier to grasp idea like order. Now, I understand that this is thinking a little too much about something that we learn very early in life. However, it is necessary to understanding why our brains sometimes lose count. When we begin counting, we are making a concession with ourselves. Essentially, we are asking a question: how many items are in a group? And when we realize that that question is too difficult for our brains, we do not admit defeat. But we do the one thing that we as humans can do when faced with an impossible question. We ask a better question. How many steps along my poem of counting numbers do I go if each step corresponds to one of the items in my group? Subitizing is essentially the mindset of question, how many, and immediately reaching the goal of understanding quantity. Counting takes the question how many, then shifts focus, and the new question becomes where are we on the number line? We reach some intermediate goal of understanding the location of where on the number line we are, and then we finally correspond to a quantity, and we understand how much we have. Losing count is akin to getting lost. We used location on the number line to give us an essence of how many. When we're no longer confident of where we are in the list, we no longer have any certainty of the eventual quantity after the exhaustion of our items. It's like when we forget whether we've sung a certain verse of a song or not, and end up singing the wrong line, or when you're not paying attention to the first few minutes of dialogue in a movie and need to start over to get the full picture. We lose exactly where we are, and because that is so vital to knowing our amount, our eventual quantity, we must start over.